we covered section 2.2, solving quadratic equations. We have learned 4 methods to solve quadratic equations: solving by factoring, solving by using square root property, solving by completing squares, and solving by using the famous quadratic formula. And we have one thing left in section 2.2. It's the application of quadratic equations. So we are going to cover this problem. And this problem happened to be the problem one of the students asked through email. The numbers might be different, but the question is the same type of question. The background, everything is the same. Let's read this problem. Application problem is just a word problem. It has a lot of sentences, and you need to take time to understand them thoroughly. A farmer needs to enclose 3 sides of a pasture with a fence. The 4th side is a cliff wall. The farmer has 45 feet of fence and wants the pasture to have an area of 252 square feet. What should the dimensions of the pasture be? Parentheses. For the purpose of this problem, the width will be the smaller dimension, needing 2 sides. The length will be, the length with the longer dimension, needing 1 side. They tell you, okay? Drawing a diagram to help you understand what's going on is a good idea, right? Let's say this is a cliff. This is a cliff wall. The pasture should be a rectangle. It mentions width and length, 4 sides. So it must be a rectangle. One side is a cliff wall, and it has 2 widths, right? This is a width, this is a width. It has, for the purpose of this problem, the width will be the smaller dimension, needing 2 sides. The length will be the longer dimension, needing 1 side. So this is the length. I use capital letter L to represent length. W represents width, needing 1 side. Additionally, the length should be as long as possible. The length should be as long as possible, okay? So we are looking for the dimensions of the rectangle. We need to find the length and the width. We are going to only use one variable, all right? Do you want to use variable, let's say we bring x in the problem. Do you want to use variable x to represent the width or length? Yeah, what other information we have? We know the farmer has 45 feet of fence. We know the farmer has 45 feet of fence. It kind of like the parameter of the pasture, right? Excluding the side next to the cliff wall. And we also know the area, 252 square feet. In this case, it really doesn't matter what do you want the x to be. I will assign x to be the width, all right? If you don't disagree, I'm gonna let the width be x. Then let's see how do we write the length in terms of x as well. Let's see how do we write the length in terms of x as well. The 3 sides, this side, this side, this side, should be 45 feet, right? Because that's what the farmer has. So let's say the farmer used all the fence he has, so 45 feet. That means the width x plus the length plus another width, those 3 sides should use up the 45 feet fence, right? And on the left side of the equation, we can combine the 2 x's. Then we have L plus 2x. If we minus 2x from both sides of the equation, we have L equals 45 minus 2x. So that's how do we find out the length of the pasture in terms of x. It's important you pointed out the beginning of the solution. Let x be the width. It's important. You assign x to be the width, then you have to keep the consistency the rest of the solution. Then 45 minus 2x is the length. All right, so far so good, guys. We are looking for the dimensions of the pasture. We need to know the value of the length and the width, right? We bring in one variable x. We let x be the width. And so far, we roll both length and width in terms of x. So far so good? Hello?
Yes.
Okay, very good. So now we have both length and width written in terms of x. We need to set up an equation in order to solve for x, right? In order to know the length and the width, we need to know the value of x. In order to know the value of x, we need an equation. And we do have one more piece of information in the question we have not used yet. The information is the area of the pasture. The area of the pasture is 252 square feet. What's the formula calculating the area of a rectangle? Length times width equals the area, right? Okay, length times width. Since length times width is the area of the pasture, length is 45 minus 2x. Width is x. Area is given 252. So now we have the equation, all right? We have the equation. And this equation is a quadratic equation. We are using a quadratic equation to solve this real-world problem. So that is seen as an application of a quadratic equation. Let's solve the equation. Left side. If you want, you can switch the order of x and 45 minus 2x. Let's distribute. X times 45, 45x. X times negative 2x, we have negative 2x squared equals 252. And what I'm going to do is I'm going to move everything to the right side. The reason is because I want the coefficient of x squared to be positive. I do not like the coefficient of x squared to be negative. For that reason, everything gonna move to the right side. There's this technique is called side and sign. I have this method taught in my foundation 2 class. It says that we can move the terms in the equation anywhere we want. For example, if I want to move negative 2x squared from the left side to the right side, I just do it. But at the same time, I change the sign in front of it. The yellow term is negative on the left side. So when I moved it to the right side, it becomes positive. All right. Similarly, the blue term, 45x is positive. When I move it over to the right side, it will become negative 45x. And 252 stay on the right side. So we have 252 here. All right. And then now I'm going to switch the left side and the right side again. I have 2x squared minus 45x plus 252 equals 0. Let me double check before we proceed. 2x squared minus 45x plus 252. That's correct. Now we are going to solve this equation. This is a quadratic equation. What method should we apply? We can use a quadratic formula. or we can try to factor. Let me see if I can factor it. If we use, how about let's use the quadratic formula, because that's the focus of this section. And then let me write the formula right under. Then it can help you to determine the values for ABC. A here is 2. B here is negative 45. C here is 252, right? ABC. Do you guys remember what is the delta represent? Delta is called the discriminant. The formula for the delta is B squared minus 4AC. Let's plug it in. B is negative 45. Put it in the parentheses. A is 2. C is 252. Okay, let's see. What is 42 to the power of 2? I'm getting a calculator. 45 times 45, 2025. And minus 4 times 2 times 252. So 4 times 2 times 252. That is 2016. 2016. And 2025 minus 2016 give us 9, right? So delta is 9. And the famous quadratic formula, x equals negative b plus minus big square rule. Under the square rule, we have the discriminant, right? And all over 2a. Now let's plug in the quadratic formula. B is negative 45 right here. For some reason, this is a common mistake, especially when B is negative. B is negative 45, so the opposite of B, understand this here as the opposite of B. The opposite of B is positive 45. And plus minus square root of 9. Sigma is found. Value is 9. Denominator is twice of A. A is 2. Twice of A is 4. Okay? What is root 9? Root 9 is 3. So we have 45 plus minus 3 all over 4. And let's see the two solutions. When we take the addition, we have 45 plus 3 over 4. And that is 45 plus 3 is 48. Over 4 is 12. If we take the subtraction in the numerator, 45 minus 3 all over 4. 45 minus 3 is 42. 42 divided by 4. 42 is not divisible by 4, but we can cancel a common factor 2, and that gives us 21 over 2, right? 21 over 2. Excuse me. So the other solution of the equation is 21 over 2. 21 over 2. So we got the two solutions. Do you guys remember what does x represent in this application problem? You're gonna go back the very beginning of the solution. We let x be the width. So we got the width right now, right? We have two values for the width. Now let's figure out the value of length. Two cases, right? When x equals 12, that's the first solution we got. Then the width is 12. And the length, look at here. The length is 45 minus 2x. 45 minus 2x. Plugging in, x equals 12. So we have 45 minus twice of 12 is 24. 45 minus 24 is 21, right? So the length is 21. The width is 12. That's one solution. What if x equals 21/2? We got the second solution earlier, right? When x equals 21/2, then width is 21/2, and length, which is 45 minus 2 times x. We can replace x with 21/2, right? 45 minus twice of half of 21 is just 21. And 45 minus 21 gives us 24. Okay, so in this case, the length is 24. The length is 24. Width is, if we rewrite this as decimal, is 10.5. 10.5. So the length is 24. The width is 10.5. We should always double check our answer when we solve an application problem. The checking part actually is easier than the solving part, the solution part. We have two set of solutions. The length could be 21 and the width could be 12. Let's check, all right? Let's check. Let's do the algebra. If the length is 21, width is 12, we have two widths. So here's 12. Here's 12. Here's 24. No, hold on. 21, my bad. 21. So now we are talking about the first set, right? First set. If the width is 12, the length is 21, then added together, we have this 24. 24 plus 21 is 45. So 45 is all the fence that the farmer has. What about the area? If we multiply the length by width, 21 times 12, let's see, 21 times 12, the area is 252. So the first set is correct. Let's see the second set. This is the second set. Don't rush, okay, guys? Do not rush. Take your time, especially when it's an application problem. A lot of information, be very careful. So the length, the second set, length is 24, width is 10.5, 10.5. 12 of twice of 10.5 is 21. 21 plus 24 is 45. That's all the fence the farmers have. That works as well. Regarding the area, let's see what is the length times the width. 24 times 10.5. 24 times 10.5. Also 252. So we have two set of solutions. However, there's a very important information here. The last sentence is a very important information here. It says the length, additionally, the length should be as long as possible. Look at the two sets of solutions we got. The first set right here, you should be able to see my arrowhead, right? Length is 21, width is 12. The second set, length is 24, width is 10.5. Which has longer length? Which set of solution has longer length? I'll wait for you to respond me.
The second solution.
Yes, 24 is longer than 21, right? That's the reason we're going to get rid of this one. Only take the second set of solutions. Because the last sentence in the problem. Every sentence matters, okay? Maybe sometimes the problem has some sentences doesn't really help. They are just distracting you. You still need to take time to understand those information. The last sentence is very important. We want the length as long as possible, all right? As long as possible. So we should take the the second set of solution. Because the farmer only need one set. The farmer only need one solution, okay? That's the solution he wants. Did I answer your question? I think Max emailed me asking this question, right? Is it clear?
Yes, ma'am, it is.
Okay, very good, perfect. So I include one application problem, and that happened to be the one you asked. There are more other water problems in Lumen. If you need help, just feel free to email me. Okay. So that's everything from section 2.2. Quadratic equations. Now let's move on to section 2.3. What do we do in section 2.3? The title of section 2.3 is extraneous solutions. Title is about extraneous solutions. But in fact, in this section, we need to learn 3 types of equations. Yes, in this section, we continue solving equations, but not quadratic equations anymore. We are going to solve 3 important types of equations. The first type, rational equations. Second type, radical equations. Third type, absolute value equations. A lot of things. Yeah, I'm gonna let you know. Actually, I normally cover one type of equation in one class. Now, the design of the course is we need to cover those 3 different types of equations in one section. Okay, we'll try, all right? The first type, topic 11, solving rational equations. Is good. It's always good to know the names, to know the names of the concepts. When we learn something, we want to look like a professional, right? Yeah, when you learn a new language, you want to know the important terminologies and the grammars. What is a rational equation? What does a rational equation look like? Firstly, it's an equation, right? On top of that, of course, is equation. Rational equation is an equation containing rational expressions. Here, you might want to take notes and write this definition down. What is a rational expression? Rational expression is a polynomial over a polynomial. It's very important. In Foundation 2, you have studied polynomials, right? I assume you know the definition of polynomials. What is a monomial, binomial, trinomial, and a regular polynomial? And you also have learned how to plus, minus, multiply, and even divide polynomials, right? But we know if you add 2 polynomials together, you have a polynomial. If you subtract 2 polynomials, you get a polynomial as a result. And if you multiply 2 polynomials, you still have a polynomial as the product. However, if you divide a polynomial by a polynomial, we do not necessarily have a polynomial as the quotient. And what we have as the quotient? Rational expression, okay? Rational expression is the quotient of 2 polynomials. I think it will be great if you can understand and remember this concept. Rational expression. Rational expression is a quotient of 2 polynomials. Look at this equation. The first part, 1 actually is a monomial, right? Yeah, I know it's a constant, but it's a monomial with degree 0. And the denominator x minus 3 is a binomial degree 1. Polynomial over polynomial, this is a rational expression. This part, x is a monomial degree 1. Denominator x plus 3, binomial degree 1. So polynomial over polynomial. So again, rational expression. On the right side, numerator, negative ax plus 30, binomial degree 1. Denominator x squared minus 9, degree 2, but is also a polynomial, right? Polynomial over polynomial, rational expression. So if you have an equation containing rational expressions only, That is a rational equation. We have a procedure. We have a procedure that you can apply to solve any rational equations. But you have to know what is a rational equation, then you know when to apply the procedure. And I explained how do you know an equation is a rational equation, right? Yeah, it has rational expressions in it. And what is rational expression? Polynomial over a polynomial. That's it. Okay, the procedure has, I think, is 5 steps. Let me write it down, okay? Step 1. Step 1 is we factor all the denominators and identify the exclusive values of x. I'll explain. First step is to simplify. Factor all the denominators. For one reason to do that is to identify the exclusive values. Okay, let me show you what I mean. On the left side of the equation, we have, I like to use an imaginary line. I like to use an imaginary line to break the left side and the right side, separate the left side and right side of an equation. Okay, the left side have two parts, right? The first part is 1 over x minus 3. X minus 3 cannot be factored. It's already prime. Even if it's prime, I would use a parenthesis to frame it. All right, so that's what I do for that term, for that part. And the second part, and I need more space, sorry. 1 over x minus 3. Second part, x over x plus 3. X plus 3 is also not factorable, it's just a binomial. So I use a parenthesis to frame it. On the right side, however, numerator negative 8x plus 30, denominator is factorable, right? Okay, let me test you how much you have learned from Foundation 2. How do you factor x squared minus 9? A hint, 9 is 3 squared. How do you factor x squared minus 3 squared? That's why I told my Foundation 2 students, if you don't know how to factor polynomials, you cannot do pre-calc. Yeah, how do you factor x squared minus 9? I need help. Yeah. Who would like to help me to factor x squared minus 9? It is x squared minus 3 squared, right? It is a special binomial. It's a difference of 2 squares. Anybody remember that?
One would be x plus 3 and the other one would be x minus 3.
Exactly. Thank you. Awesome. I don't see who is talking. Who is talking?
Michael.
Michael. Awesome. Thank you, Michael. Exactly. So the denominator can be factored as x minus 3 times x plus 3. Perfect. Exactly. If you have trouble to do this, watch the videos I posted. All right. Very good. So we factored the denominator in the expression, rational expressions, right? One purpose to do that, one reason to do that is to identify the exclusive values. What is exclusive values? We all know by common sense, denominators cannot be 0, right? Denominators can never be 0. Yes. So tell me, could x be 3? Could x be 3?
No.
Oh, yeah. So I would do this, okay? I would, here is fine, okay? Put a comma here and then write x cannot be 3. Obviously, x can't, right? If x is 3, then this denominator is 0, then we can, that's not well defined. Could x be negative 3? Could
No.
x be negative 3? No. Same reason. If x is negative 3, then the denominator of the second part on the left side is 0, right? Same idea. you look at the denominator that factored on the bottom. X cannot be 3, X cannot be -3, right? Yeah, the 3 and the -3 are the only two exclusive values of X. That means the very beginning we know, because we are solving for X. Basically, we are looking for the value of X that would satisfy the equation. From the very beginning, we know X cannot be 3, X cannot be -3, all right? Okay, that's the first step. Second step, I need more space. Sorry about that. Need to get rid of that. Insert page break. Okay, now we have enough space. Second step. Step 2. Find the LCM of all the denominators. Okay? LCM, GCF is something I constantly talking about in Foundation 2. GCF, LCM, and you continually using them in pre-calc, even in calculus. You have to use them all the time. So anybody know what does LCM represent?
Least common factor or multiple.
Exactly. Yeah, least common multiple. Yeah, least common multiple, exactly. All right, so we have 3 denominators as you can see. The first denominator, x minus 3, I use parentheses. I use parentheses to show you x minus 3 as a binomial is one whole thing. So do not see x and -3 as like separate thing. X minus 3 is one whole thing, one binomial. And the second denominator, x plus 3. And the third denominator, x minus 3 times x plus 3. Okay, those are 3 things, all right? If that helps, maybe you, so it's blue, yellow, green. Yeah, that's supposed to be green. We are looking for the LCM of those 3 things. How about let me give you something similar and easier. Can you help me to find LCM of 3, 5, and 15? If we have 3 numbers, the 3 numbers are 3, 5, and 15. This has nothing to do with the problem, okay? It's just like a review and bring your memory from LCM. Can you find the LCM for 3, 5, and 15? The least common multiple. So the number has to be multiple of all of them, and it has to be the smallest common multiple. What's the least common multiple of 3, 5, and 15? Least common multiple. So the number needs to be multiple of 3, also multiple of 5, also multiple of 15. And it has to be the smallest common multiple of the 3 numbers. Anyone would give it a try?
Is it not just 15?
Yes, correct. Yeah, I don't see who is talking, but yes, correct, exactly. Yeah, Max, okay, awesome, very good. Yeah, this one is kind of special because 15 happened to be, because 3 happened to be a factor of 15, 5 also a factor of 15, right? Yeah, 3 times 5 is 15, and 15 is the smallest multiple of itself, and also multiple of the other 2. So that makes 15 the smallest common multiple of 3. Same idea here. All right? Do you see blue multiply yellow is green? So green is a multiple of blue. Green is a multiple of yellow. Green is a multiple of itself. Yeah, I make it very clear. Yeah, let me say that again. The green is a multiple of blue. Green also multiple of yellow. And the green is also multiple of the self. Is smallest multiple of the self. So what is the LCM of the three things? Yeah, what's the LCM of the blue, yellow, and the green?
The green.
Perfect, exactly. LCM in this case is the green, x minus 3 times x plus 3. All right, okay. So that's the step 2. We found the LCM of all the denominators. Step 3, multiply all the parts of the equation by the LCM to eliminate the denominators. All right. Multiply all the parts of the equation by the LCM we just found in step 2. Purpose is to eliminate the denominators. Okay, we're gonna multiply the green, all right? X minus 3 times x plus 3. So we're gonna do that for the first part. Multiply by x minus 3 times x plus 3. And that's the same with multiply by x minus 3 times x plus 3 over 1, right? Yeah, it's like when you multiply something by 2, isn't it the same with you multiply the thing by 2 over 1, right? Because the thing is a fraction, so you write 2 as 2 over 1 would be helpful. Yeah, so here, the first part, we multiply by the LCM. Second part, we do the same thing. A little bit crowded, sorry about that. X minus 3x plus 3 over 1. And I think I want to move this part. Okay, I'll erase it and run it again. So the exclude value, x cannot be 3, x cannot be -3. All right, so the right side multiply by the LCM, x minus 3, x plus 3 over 1. All right, purpose is to eliminate denominators. Okay, let's see how do we eliminate denominators. I'm gonna use a gray color. This gray would help. Okay, x minus 3 on the bottom, x minus 3 on the top. They cancel each other, right? I hope you agree on that. Here, x plus 3 on the bottom, x plus 3 on the top. They cancel each other. And here, x minus 3 on the bottom, x minus 3 on the top, x plus 3 on the bottom, x plus 3 on the top. All those gray, they're gonna go away. All right? Those gray color, they disappear. They're gonna disappear. And the leftover, let's clean it up. The first part only have nothing on the bottom, right? You will see the bottom are all gone. All the denominators are eliminated. So we won't have denominators anymore. And the first part is just x plus 3. If you want, you can still keep the parentheses, doesn't matter. And the second part, we have x left on the top, also x minus 3 left on the top. Bring down the equal sign in the middle. And then on the right side, we have negative 8x plus 30 left on the top. Right? Yeah, double check always. Okay, looks good. And step 4. After you eliminate all the denominators, solve the resulting equation. Solve the resulting equation. Solve this equation we just got. This equation is easy to solve because there's no denominators, right? It looks like a quadratic. Let's see. Parentheses, this one could literally remove because the coefficient is 1. So x plus 3. And distribute x times x, x squared. X times negative 3, negative 3x. On the right side, negative 8x plus 30. On the left side, can we simplify something? Okay, I'm gonna use my technique. It's called silent sign to move everything to the left. All right, I want to keep the right side be 0, so I'm gonna have x, copy everything, plus 3 plus x squared minus 3x. I'm gonna move negative 8x over, so I have a positive ax. Move 30 over, so I have negative 30. Keep the right side as 0. Left side, combine like terms. We have x squared by itself. And we have x, 8x, that's 9x. 9x minus 3x, that is 6x. All right. And we also have 3 minus 30, that is negative 27. Okay, let me double check. Yeah, always double check. X squared, so 9 minus 3, 6, that's good. And negative 27, that's correct. All right. So this is a quadratic equation. Last section, we just covered quadratic equation. I'm gonna give you 2 minutes. Whatever the method you like, solve the equation and let me know what's the solutions of this quadratic equation. All right. Give you 2 minutes. Right now it's 15. I'll check on you in at 17. X squared plus 6x minus 27 equals 0. Okay. What do you have, guys?
The answers are 3 and negative 9.
Awesome. Very good. Perfect. Yeah, actually, this problem solving by factoring works. We can factor the left side as x minus 3 times x plus 9, right? Negative 3 and the positive 9, they multiply to negative 27, add up to positive 6. And if I highlight the two numbers in red, their solution would be their opposites, right? Positive 3 and negative 9. And you don't have to, again, you don't have to use a factorization. You can use quadratic formula. So you should have the same result, 3 and negative 9. Very good. But we are not done yet. Remember, the procedure has 5 steps, and the last step is very important. Check the proposed solutions and get rid of the extraneous solutions. All right. Yeah, extraneous solutions, that's the title of this section, extraneous solutions. And this equation does have extraneous solution. So we have, after you solve the quadratic equation, you have to propose the solution, right? 3 and negative 9. However, look at it here and then compare it with what you had from the first step. From the first step, did we get the exclusive values? The very first step, we already see x cannot be 3, x cannot be negative 3, right? So do you see a contradiction? Here it says x cannot be 3. Here it says x equals 3. That's a contradiction. So 3 is extraneous. we cannot keep 3. We have to get rid of 3 and keep one solution only. So the solution set of the equation only have one solution, that is a -9. And guys, you are allowed to use any type of calculator. So now you know -9 is the solution. Why don't you just plugging in the original equation just to get the one more guaranteeing your solution is correct, to plugging in to see if it satisfies the equation. But if you process the 5 steps correctly, you don't have to plug back in. It's just a recommendation, okay, suggestion. It'll be good if you always plug in. And step 5 mainly is to get rid of the potential extraneous solutions. And that's the 5 steps to solve rational equations. Let's summarize. The first time or first a few times when you apply the process to solve rational equations, it might take a very long time, but once you practice enough, it will become a lot easier. All right. First step, work on the denominators. Factor those denominators that are factorable. The purpose is to identify the extraneous values for x. And you can tell, once you have them factored, you can tell quickly x cannot be 3, x cannot be -3, right? How do you know? Because this is a -3, and so it's opposite, would make the denominator be 0. Here's a +3, so it's opposite, will make the denominator be 0. And this is -3, +3. So they are opposites. X cannot be their opposites. So find the exclusive values for x. Step 2 is to find the LCM of all the denominators. This part, actually, this step is what I worried. LCM of the denominators. Do not overthink. Just think about, just try to understand what is LCM. How to find the least common multiple of all the denominators. I believe you can figure it out. Once we have the LCM found, we multiply all the parts by the LCM. Purpose is to eliminate all the denominators. Because x is in the denominator. If we don't get rid of the denominator, it's not possible to eventually isolate x, right? Or solve for x. And step 4 is to solve the resulting equation. That is just a simple quadratic equation. Step 5, very important, is to check the solution, which is the proposed solution, and get rid of the extraneous solutions. So far, so good, everybody? Do you have any questions about this problem?
Nope.
Okay, very good. Yeah, I believe I'm recording the class. Just double check. Yes, it's automatically. Yeah, one thing about Zoom is automatically is recording. All right. Next question is also a rational equation. Oh, this one's not. This one. Yeah, this one. I'm getting more space though. Insert a page break. I include 2 problems about rational equations. The reason I include this one, because this rational equation is special. This rational equation is a proportion. That's the reason I put it here. It's a proportion. Proportion. A lot of concepts, right? Just to let you know, for your information, if you just use the 5 steps to solve this equation, totally fine. You will get the correct solution. But it is a special type of rational equation. It is a proportion. What is a proportion? Any equation that has this structure, like a butterfly, very symmetric, kind of symmetric, right? The left side has a quotient, top and the bottom. Right side has a quotient, top and the bottom. If you have an equation look like that, that is a proportion. We do have a proportion here, right? Left side, quotient, top, bottom. Right side, quotient, top, bottom, right? Okay. So for proportion, we have 4 steps. We have 4 steps. Step 1. Same thing, factor, denominator, identify exclusive values of x. So here we already have the factor, they are not factorable, okay? So the exclusive values, x cannot be 1, right? X cannot be -2. How do you know? -1 here is the number with x. Its opposite, the positive one, is the exclusive value. Same thing here, +2, x plus 2. So its opposite -2 is the exclusive value, right? So that is step 1. Identify the exclusive values for x. Very important. Step 2, cross multiply to get rid of, to read denominators. Okay, you might remember cross multiply, this name, right? It's different from multiply cross. It's cross multiply, like this. Okay, what is cross multiply? The order doesn't matter. So basically, you rewrite the proportion. Maybe you multiply those two parts. Okay, you multiply those two parts and equate that with the multiplication of those two parts. Right, so that is cross multiply. So I'm gonna do the blue first. 5 times x minus 1. And then on the right side, I'm doing the green. 4 times x plus 2. And no denominators. It is special. So when we have something special, we should treat them specially as well. Yes, this is a rational equation. You totally could apply the procedure I just gave you, but it is a proportion as well. Since it's a proportion, we can use a cross multiply. Just like that, you don't have to worry about LCM or whatever, right? Just cross multiply. Okay, step 3, solve the resulting equation. Solve the resulting equation. When you learn mathematics, what do you actually learn? You learn those things I'm trying to give you, trying to sell to you. You don't come up with something else, or you need to treat those things seriously. Okay, I forgot to do this, right? I forgot to do the line, the imaginary line. Okay, so now we distribute 5 times x, 5x, 5 times -1, -5. On the right side, distribute 4 times x, 4x, 4 times 2, 8. And then I'm going to keep 5x on the left side, move 4x over. You can solve this the other different way. You know how to solve it from foundation. So I'm gonna just do this my way. Move 4x over, positive become negative. And move this 95 over, negative become positive. Just like that. All right, 5x minus 4x equals 8 plus 5. 5x minus 4x is x. 5 plus 8 is 13. Not done yet. Step 4. Check proposed solution and get rid of extraneous solutions. Okay? Our proposed solution is 13. Our exclusive values we got from the very beginning, 1 and -2. Do you see any contradiction? Do you see any contradiction? If not, I don't think you do, right? If not, keep 13. So 13 is the solution, right? 13 is the solution. This rational equation is special. This rational equation is a proportion. So we can treat it specially. Just use cross multiply. But important thing, same important with the previous problem. Step 1 is the first step and the last step. First step, identify the exclusive values and write it here clearly. And the last step, check your proposed solution and to see if you have any contradiction. If you do see contradictions like we had earlier, here is x equals 3, here's x not equal to 3, then that means 3 is the extraneous solutions. You have to get rid of it, right? But if you don't see contradiction like this one, then that means you do not have the extraneous solutions, right? Okay, here, one more thing before we move on. Why we did not do this when we solve a linear equation, a quadratic equation, but we have to consider extraneous solutions when we solve rational equations, is because the rational equation, it has a domain as well, okay guys? The domain consider as all the possible values for x that make the expression meaningful, well-defined in the equation. And the domain of the equation is all real except 3 and -3. So the domain is restricted because it has a denominator, because the equation has x in the denominator. So x cannot be a certain value or values. Yeah, we can understand that as the domain is restricted. However, step 3, when we get rid of the denominators and getting the resulting equation, this quadratic equation, we removed that restriction. When we remove that restriction, the domain is expanded. There's no restriction for this quadratic equation. Any x would make the quadratic equation meaningful or well-defined. For that reason, when you expand your domain, you might invite in extraneous solutions. And that extraneous solutions is in the domain of the quadratic equation, but not in the domain of the original rational equation. So we have to check. Simply put, we have to check the extraneous solution if we have variable x in the denominator of an equation. Okay. So if you have no questions, we're gonna move to the next type of equation, radical equations. We also have procedures. What time is it? 20 minutes, okay. More space, okay. Second type of equation we are going to learn is a radical equation. How do we solve radical equations? And we also need to know what kind of equations are radical equation. It's not if you have a radical, it's counted as a radical equation. You have to have a variable x in the radicand of the radical. In other words, you have a variable x under the radical symbol. So this is the radical symbol, right? You need to have x appear under the radical symbol. If you have an equation, let's say is x plus root 2 equals root 3. It also have radicals, but this is not radical equation. This is just a simple linear equation. The radical x is not involved in the radical. All right, I hope that's clear enough. Okay, we have a procedure. Step 1. Observe to see how many radicals do you have. Okay, the first step is to isolate the radical. If you have more than one radicals, I'll show you later. We have questions that involve 2 radicals. Then you isolate one of them. For this problem, this question, there's only one radical, square root x plus 149, right? And you isolate that radical. And sometimes it's already isolated, like this one, already isolated. On the left side of the equation, we have square root x plus 149 by itself. Everything else to the right side. So if sometimes it is not there yet, then you have to isolate the radical. Step 1. Step 2, raise both sides of the equation to the nth power. N is the index of the radical. Okay, I mentioned this before, right? I mentioned this is called a radicand. This is called a root number or index. This is called an index. Okay, I need to write it down. A radical look like this. All right, and n here is called index or root number. The star here, whatever the whole thing under the radical, is called the radicand. Okay, so the root number in our case is 2. You don't see it because it's a default. We don't really write it out when it's a square root. And the step, okay, let's do that. The first step is already isolated, right? Is already isolated. Second step, raise both sides of the equation to the power of n. I need your help. Power of n, what is n here? What should I?
2.
2, perfect, exactly. Second power, exactly. To do this is to get rid of the radical, okay? Taking square root and squaring, those two processes are inverse of each other. We have been seeing this idea over and over again, right? When we talk about inverse function, or when you standing here, you walk to the right 3 steps and walk to the left 3 steps, those processes inverse cancel each other, right? Same idea, taking square root and squaring, those two processes cancel each other. That's why when we raise the left side to the power of 2, when we raise the left side to the power of 2, this square cancel this square root, and the radicand is released from the square root. So we only have x plus 149 left on the left side. The reason we raise the left side to the power of 2 is to get rid of the square root. The square would cancel the square root. Then now the left side, we have x plus 149. We don't have square root anymore. On the right side, we also have to raise to the power of 2, because we have to treat the equation, each side of the equation the same, okay? Do you know how to do that on the right side? You can FOIL, if you want, you can FOIL. X plus 17 to the power of 2 is x plus 17 times x plus 17, right? You can FOIL. Or you can use the perfect square formula. Square of a plus b is a squared plus 2ab plus b squared. That's also a formula we learned from foundation 2. I'm going to use this formula quickly, all right? If you need more details, you can use the FOIL to expand the right side. I'm going to use the formula x squared plus 34x plus 17 squared. Let's see, what is 17 squared? 289 probably. 17 times 17, yeah, 289. 289. 34 is twice of 17. So I have the right side taken care of, the square. And I see this equation is a quadratic equation. I'm going to move everything to the right side. Copy, copy, copy. Move x over. Positive x become negative x. Move 149 over. Positive become negative. And simplify the right side. X squared, 34x minus x, 33x. 289 minus 149. That gives 140. 9 minus 9 is 0. A minus 4 is 4. 2 minus 1 is 1. 140. And then I switch the sides. I have x squared plus 33x plus 140 equals 0. Okay, 3 minutes. 3 minutes to solve this equation. That's step 3. Step 3, once we have the radical removed, solve the resulting equation, the one without radical. We definitely cannot finish the section today. So many things. We would have to cover absolute value equation next time.
I got answers -5 and -28.
5 and 28.
That's what I got too.
Perfect. $14 times 10. 14 times 10, so 28 times 5. 28, 5, add up 33. Very good. Awesome. Positive 5. Positive 28. Okay, so we solve the equation. We have x equals -5 and x equals -28. But not done yet. Step 4. Check by plugging in the original equation to read the extraneous solutions. Okay. If you don't see what the word is a little cursive, just let me know. I'll tell you what is it. Check by plugging in. Yeah, this step, very important, but it's a little bit troublesome. When we solve rational equations, the checking part actually is very simple. You don't really need to plugging back the original equation to check. All you need to do is to compare your proposed solution with the exclusive values you got at the very beginning. Is you can see here and here, right? The checking part actually is important, but not troublesome. It's pretty simple. It's easy to do. But when we solve radical equations, you are required to plug in back. We have two proposed solutions here, right? We are required to plug those proposed solution back into the original equation to check. Okay, that's the only reliable way to do that. Okay, let's do that. Let's plug in. Let's use different color. Plug x equals 95 into the original equation. The original equation is square root x plus 149 equals x plus 17, right? Okay, let's plug in. So x is 95. 95 plus 149, x plus 17. 149 minus 5, 144. X plus 7, oh, I'll count the x here. Sorry, x is 95. X is 95 here, 95, 95, 95. And then we know square root of 144 is 12. And 95 plus 17 also 12. When we get an identity, we get a true statement. Okay, we really sure. Yes, 95 is a solution. We keep this. Okay, we're gonna keep this. But now we have another proposed solution. Let's plug x equals -28 into the equation. Okay, so into this x plus 149 equals 95 plus 17. Oh, sorry, x plus 17. X plus 17. All right, x plus 17. So we have -28 plus 149 under the square root. And here, x is -28 plus 17. Under the square root, we have square root of 121. On the right side, we are going to have a negative number. Be very careful. -28 plus 17 is -11. Right side is -11. Left side square root of 121 is +11. That is a contradiction. So -28 is extraneous solution. We have to read it, get rid of it. And now we can conclude the equation, the radical equation, only has one solution, and the only solution is -5. -28 is extraneous. Why do we have this extraneous solution when we solve a radical equation? Same idea with rational equation. Because we have a variable x. Because we have a variable x under the square root. And we know the radicand under a square root has to be non-negative. Okay, I can write it here. This is one important thing. And another important thing, the radicand under square root has to be bigger than or equal to 0. On top of that, the range also is non-negative. So square root of x plus 149 cannot be negative. That means x plus 17 cannot be negative. So simply put, the domain is restricted. But once we get rid of the square root, we end up with a quadratic equation. That quadratic equation has no limitation, no restriction on what x can assume. So when we expand the domain, we invited in the -28. It is a solution of the quadratic equation, but it is not a solution of the original radical equation. It's not even in the domain of the radical equation. Do you see that? So I want to emphasize, when we solve a radical equation, the checking part is you plugging in the original equation. You plug the proposed solution into the original equation. It's different from a rational equation. Rational equation, you just compare, right? So this is different. We have 2 minutes. I think we can do something quick. This one can be done quickly. This one. X minus 1 to the power of 3 over 5 equals 8. You might wonder, this is a radical equation? I don't even see the radical, right? It is radical because left side can be written as a fifth rule of x minus 1 to the power of 3. It is radical. So the idea for this one, idea is to raise both sides of the equation to the power that could get rid of the radical, that could isolate x minus 1. So to do that, we are going to raise both sides to the power of 5 over 3 instead. Okay? This is a little bit different. This one is a little bit different. So we want expose x minus 1 because we want to solve for x, right? but now x is trapped in the exponential form. So we have to get rid of the exponent. How do we get rid of the exponent? We raise both sides of the equation to the power of 5 over 3. After that, 3 over 5 times 5 over 3, they cancel each other, right? Use the power we learned from foundation 2. Remember the power rule, x to the power of n and n to the power of m equals x to the power of n times m. This is also a very important formula. So the left side, 3 over 5 times 5 over 3, they cancel each other. They equals 1. So we have x minus 1 isolated. On the right side, we have 8 to the power of 5 over 3. And then plus 1 to each side, we have x equals 1 plus 8 to the power of 5 over 3. Of course, we need to simplify. What is 8 to the power of 5 over 3, right? It takes a little bit knowledge from the exponential formulas. We can write 8 as a 2 cubed. And apply the power rule one more time. Keep the base 2. Multiply the two exponents. 3 times 5 over 3. The 2 3's cancel. We have 5 here. 2 to the power of 5 is 32. 2 times 2 times 2 times 2 times 2. So it's 33. And do we need to check the result? Do we need to check the result? You know, we don't have to. It is a radical equation. How come we don't have to? Because the root number is odd. The left side, if we write it as the radical form, is fifth root of x minus 1 to the power of 3, right? When the root number is odd, we don't have to check. But it's always good to check. I would not say no, you can't check. It's always good to check the equation, especially when you are allowed to use a calculator. Same idea, this problem, you don't have to check because the root number is 3. When the root number of the radical is odd number, 3, 5, 7, 9, technically you don't have to check, but it's always good if you check. But if the radical has root number even, you will have to check. It's a completely different story, very different. Okay, we ran out of time. We would have to handle absolute value equation on Tuesday. Do you guys have any questions?
Nope.
No, then you guys have a good weekend. Keep working on Lumen. There's a function that you can practice different but similar problems. Try to use that function as much as you can. If you have no questions, I'll see you on Tuesday. If you have questions, you are welcome to stay, all right? I'm gonna stop the recording from this video. Stop the recording. Let's see how we do that.
Thank you. Goodbye.
Thank you. Bye-bye.
Thank you. Bye.
Bye. Pause.
Bye. Have a good weekend.
Thank you, you too. Bye-bye. All right, I stopped the recording. Are you sure you want to stop recording to the cloud?
Yeah, we can stop recording.
Yeah, if yes,
Yeah,
you will receive an email notification when the cloud recording is ready, okay?